this lesson, lesson 8, we're going to be focusing on adding and subtracting polynomials. There are two instructional outcomes that go with this lesson. The first one is to understand that the sum or difference of two polynomials produces another polynomial and relates polynomials to the systems of integers. The second one is simply to be able to add and subtract these particular polynomials. So the lesson starts off with a piece of information that's not within the module book, and that's some examples of a polynomial expression. Now, what is in the book is the statement that's at the top, these two-part statements, that a polynomial expression is either one of these two things: a numerical expression or a variable symbol, or number two, the result of playing two previously generated polynomial expressions into the blanks of an addition operator, such as this one, or a multiplication operator. Now, it's important really that the students have an idea of what a polynomial is, so the teacher will give several examples, such as 7x plus 4, or 3x squared plus 2x plus 1, or one of the other three that's in the table. And so we talk about how to classify these. And so the classification occurs by two designs. One design is by degree. And so we're looking for the students to say, well, this is a first degree polynomial, and that is because the largest exponent here is a 1. Whereas if we look at this one, this largest exponent here is a 2. This largest exponent here is a 3. This one is a 4. And because this one has no 0, it is considered what is called a constant, or if I wanted to add it, it would be x to the 0 power, and it defines our constant. So it is important that the students know linear is for first degree, quadratic is for second degree, cubic is for third, fourth degree is for 4, constant is for 0. Anything above that, let's say we had a fifth degree polynomial, such as x to the fifth, we're not going to give it a name. We're just going to ask the students to say fifth and then put the word degree behind it. So in addition to understanding by degree, students will need to be able to classify by the number of terms that are observed in the polynomial. To whereas we have two terms known as a binomial, and we identify terms because we have right here the 7x divided by a plus, which is our 4, our two terms. The trinomial, which is represented by three terms, 1, 2, 3. Oftentimes a student in the class will hear a term such as a bicycle, referring to two wheels, or a tricycle that refers to three wheels, to help the student kind of get that notion. If there's one term, such as 4x to the third power, that's a monomial. If there is two terms like this one, again a binomial, or as in this one is a monomial. Anything above 3 we just tend to describe as 4 terms, or 5 terms, or 6 terms, and so forth. But these are the special names that students are going to encounter in the classroom, that they will be held accountable for in testing situations, and so forth. So do take a moment, look at it, review it with your child if need be, and see how well they understand it, for that's how they're going to have to classify their work. A polynomial is said to be in standard form if the degrees of each term decreases from left to right. So just as an example of that, if I had a polynomial, let's say I just write 4x to the third plus 5x squared plus 2x plus 9. This would be said to be in standard form simply due to the fact that this is a 3 and then followed by a 2 and then a 1, and then this would be our constant, or our 0th case. And so as long as it's written in that notion, from decreases from left to right, it will be considered to be its standard notation or standard form for a polynomial. Now again, this is a short lesson, so a lot of the emphasis is on this particular slide here of giving the students the opportunity to work in small groups or in pairs, and we're simply asking them to be able to add or subtract and combine any parts that are alike. So if we look at a couple of these, in let's say part B, this is 4x squared, and we have a 2x squared. The part that is alike that we're looking for is the fact that this is an x squared and that this here is an x squared. And if that's the case, then we'll take our 4, we'll add it to our 2, and we will get 6 and then x squared. We won't change the part that made it alike. That's its identifying mark, or what your teacher may call its family. So if we look at the next term, this is an x with a 1 in front, and this is a 3x, again a linear term, and so since these two are alike, we'll take 1 plus our 3 to get our 4, and again we will leave the x as it is to represent that piece. And then the final part in the back, we look at here our plus 7 and our positive 1, and so 7 plus 1 will give us 8. We note, just for identification purposes and thoughts, we are in standard form, 2, 1, and then a 0 to the x power. And if we wanted to classify this for purposes, this is a degree of 2, so we would call this a quadratic. And then there are 1, 2, 3 terms, so it will be known as a trinomial. And so this is something that a student will continue to do whether they're in part B or part C. Part C will work the same way. The only difference in part C is that they have a minus sign instead of an addition sign. But we'll note that this term and this term are alike, followed by this term being alike with this term. What is interesting is that this positive 8 is alike with this negative 7, which leaves us with this 4x, which does not have a like term in this particular problem. So if I subtracted it together, 3 minus 1 will give me 2x to the third power. And then if I look at here, this is a negative 1 minus a 5. So negative 1 minus 5 would give us a negative 6x squared. This is a minus 4x, so we'll write minus 4x. And then our like terms in green, 8 minus negative 7 give us a positive 15. And so we check for standard notation, 3, 2, 1, and then a 0th case. And so this is a cubic for being a third degree. And it has 1, 2, 3, 4 terms. So we'll call it a 4-term polynomial. In part D, we're looking at this notion where we have numbers in front of each of the terms. So the students will need to exhibit or demonstrate the distributive property before continuing on with the problem. So if I looked at that piece alone, the 3 times the x to the third is 3x to the third power, and 3 times negative 8x is negative 24, and then x. So if we go to the back part of the problem, we have a negative 2 times this and negative 2 times a 12. So when I write that, negative 2 times 3 times x cubed is negative 2 x to the third power, and negative 2 times 12 is negative 24. So we'll take a moment and see what's alike. So we have something to the third power here, and another term to the third power here. We have a negative 24x, but nothing else with an x. There is no x on this 24. And then we have this like term here. And so then I can combine what I have, 3 minus 2, and so I get 1x to the third power. We have our minus 24x, which does not have a like term. And then we have our minus 24. And again, if I classified it, we would classify this as a cubic due to the third degree, the largest degree, and then 1, 2, 3 terms. So therefore it will be a trinomial. I will leave you with E and then F. They continue in the same similar fashion in terms of how this works out. If you would like to confirm the answer for that, just email your teacher and she can let you know if you got the answers to E and F correctly.